Hello, Mr. Ryan. Are you right? Today we look at this easy question. We are given an array which has the size of 2n. N is an integer which is bigger than or equal than 2. For example, given this array which 4 elements, n equals 2. Okay, and only one number appears n times. For example, in this array, 3 appears n times, n equals 2. And there are n plus 1 unique elements. So there are 3 numbers which are unique, which is 1, 2, 3. And we want to find out number 3. And this array, look, this array, we have 6 elements. So n equals 3, right? N equals 3. And there are 4 unique elements, which is 1, 2, 3, 5. And only 2 appears how many times? 3 times. So we want to find out the number 2. Okay? So how do we solve this problem? I mean, it's actually written here, yeah? Using hash set, hash map. Okay, so given this array, because I already tell you, these are the constraints, right? This array is made up of the numbers which has these n plus 1 unique elements. So what's so special about 3? What's so special about 2 in this case? What's so special?
N amount.
Yes. How do we distinguish this with other numbers? How do we distinguish 2 with other numbers? Why is it so special?
You count.
Yeah, it counts. And then as long as we count, yeah, good idea. If we count, we found out that 2 appears more than once, 3 appears more than once, right? So we can use the hash set or hash map. We use a set to remember the numbers we have visited. If we visited from left to the right, you use the enumerate, right? Enumerate, okay? Yeah? Enumerate, what's enumerate function?
You like
Index and value. Yeah, but in this case, we don't care about the index. We just care about value. So we use the hash set. We go through the numbers from left to the right. And then if not appears, we put it in the hash set to mark down we have visited. If it appears, then that's the number. We just simply return it, right? Actually, we don't need to worry about the frequency. Okay. And the other one is using the hash map to count, right? We use the counter, right? Okay?
Yeah.
So there are quite a few solutions. Let's talk about this one step at a time. So let's talk about this solution today, and then we think about other solutions. Any solution apart from this counting thing?
Set it. Counter.
Counter is this one. So any other solution?
2-pointer.
2-pointer, yeah, we will talk about it. And also we can sort it, right? If we sort it, then we can compare the next number, right?
Yeah, but
Yeah, okay.
But that's basically brute forcing. But looking at
Another way is we
That's
can do
brute-
the math. How do we do the math?
sorted brute forcing.
Use a
brute force in a
blade.
different.
How do we do the math?
Sorted brute force in a different.
You add them
order.
up.
That's right, yes, we add all the numbers up. Okay, we add all the numbers up and then we subtract the sum of the unique numbers. And that gives the remaining, which is the duplicate, and we divide it by n minus 1, right? Yeah, we worry about that, okay?
I don't understand like subtract the unique numbers.
So for example, like this one, okay? So what's 3? How do we get a 3? It's 1 plus 2 plus 3 plus 3. This is all the numbers, right? All numbers in this array. Minus, what's the unique numbers? 1, 2, 3, right? 1, 2, 3. And then divided by how many numbers? Divided by how many numbers? Divided by only one number, right? Because here, yeah? Okay?
No, there's
N
four
minus
numbers.
1.
Sorry?
Four
Divided
numbers.
by
There's
N
four
minus one.
numbers.
Yeah, N minus
There's four
1.
numbers. There are 4 numbers.
Yeah, 4 numbers, but divided by n minus 1 because there are n plus 1 unique numbers.
What's N?
Yes!
Okay, so we
Then what's
talk-
N?
n is an integer, n times 2, right? For example, n equals 2, n times 2, 4 numbers.
Strategic.
Okay, so let's talk about this. And of course, you said the 2-pointer, right? Although I am not quite sure how to implement, but I'm sure we can use the 2-pointer thing. And also, we can use a pigeonhole here. Do you still remember pigeonhole?
Yeah, but what does that have to do with pigeonhole?
Good question. We'll talk about it in the coming lessons.
You'll never talk about it.
No. It's too much content for today. But let's worry about the attachment.
When you
I already
introduce,
know pigeonholes in my math book.
when you introduce pigeonhole,
think it's
you
pig-
never said of
I think
anything.
it's pigeonhole.
Pigeonhole. Okay,
Isn't it
there.
like pigeonhole principle?
Yeah, there are 3 pigeonholes, and
That's
they
not
are
pigeonhole. That's
they
a
are
staff.
they are 4 pigeons. So what can we get? We know at least one pigeonhole has more than 1 pigeon.
Or they
Simple.
can, or they can
Okay,
It's
so
like if there's like 15 marbles and try each different. There's five.
Go get the
Five red, 5 green, and 5 blue, and then you at least want to get 3 marbles in each pile.
Yeah, similar. Okay.
Like that, and then
Yeah.
at least how much.
Yeah.
And
Okay.
And then
Okay.
And
We
then-
worry about that in lesson 5. Okay, so today let's write this. This is so simple, right? So simple, right? Let's this array, right? Define as array. And then we just have to use the counter, right?
It's 6
C
minutes.
equals
6
counter,
minutes. 6
okay?
minutes. 6 minutes.
I know. And then we just return, right? We just return which one is for I in C. If Ci is bigger than 0, then we return I, right? Simple as that, right? Or we can use the return next.
He said rat eye.
Return next I for I in C if Ci bigger than 0. Return next, right? Next function, return next. This is the iterator, and then the next function, the second parameter is the default value when we don't find any elements in the iterator. So simple as that. This is using the counter, right? So Ci is actually, we can set it equal n. This is the similar. This is the more exact match. Or we can use the hash set, simple. For C equals set. For I in array, if I in C, we have seen it before, then return I. Otherwise, we just add it. So C dot add I. Simple question using the hash set. The time complexity O.
N.
The space complexity O.
N.
Yeah, because we're using a set, and n is the number of elements. Actually, n is the number of elements in the array. Okay, it's actually O to n, but we drop the constant. That's it for today.
Bye.
Bye bye. Bye bye.
Bye. Bye.
Bye.
Yeah.